So before we get into today's lessons on exponent properties, go ahead, try the warm-up, see what you can remember about exponents, and then we'll come back and we'll end up going over them together. So for the first one, you're actually going to end up with 3, my 3's aren't working right, 3 to the 4th power. So that would be 3 times 3 times 3 times 3. Well, 3 times 3 is 9, times 3 is 27. 27 times 3 is 81. So 3 to the 4th power is 81. Number 2 would be negative 6 squared. Negative 6 times negative 6 is positive 36. And 3 is negative 5 to the 3rd power. Negative 5 times negative 5 is positive 25. 25 times negative 5 is negative 125 is the answer for the third one. So exponent properties. This is actually going to be a 3-part lesson. We'll have spent 3 days in class going over it. The first day we're going to be talking about product properties. Properties that we use when we're looking at multiplying with exponents. The second day we'll be looking at quotient properties, or properties that we use when we're looking at dividing with exponents. And the very last day we'll be focusing on what happens if you have a negative exponent or what happens if you have a 0 exponent. We're going to skip the flowchart and jump over to the product of powers property. This is the property, this is the definition. To multiply powers with the same base, we're going to add the exponents. And that's what's really important to remember. If the base is the same, the big whole number base, we're going to add the exponents. So looking at the first one, 2 to the 3rd times 2 squared. Our bases are the same, so we can add the exponents, keep the base, add the exponents, and get 2 to the 5th. Now if you can add 3 plus 2 in your head, you don't necessarily have to write this middle step here. But for right now, I just wanted to show you what was going on. So in number 2, we're going to keep our base of 8, and 7 plus 5 is 12, giving me 8 to the 12th power. Now in problem 3, you'll notice that the first 5 technically does not have an exponent. Well, there's actually a hidden exponent of 1 there. So we're going to keep the base of 5, and 1 plus 2 gives me 3. The last one, as long as they have the same base, you can add as many of them together as you want. So I'm adding together my exponents of 6, 4, and 3, keeping my base of 4, giving me an exponent of 13. Continuing right along, 3 squared times 3 to the 7th would be 3 to the 9th. 6, we have that exponent of 1 with the 5 there again, giving us 5 to the 10th power. And 7 with the negatives, and an exponent of 1 above the second negative 7. The negative 7 is our base, so the negative just comes along, and 2 plus 1 is 3. You're still just going to add your exponents. So here we're looking at what happens if we have variable exponents. And it's the exact same thing. We're just going to take the exponents and add them. So this becomes x to the 5th power. Now in number 2, we're going to group together the 3 and the 5 and multiply them like normal to get 15. And our x to the 1st power and x to the 5th get added to give us x to the 6th. Same thing happens in number 3. The 5 and the 6 get multiplied like normal and we get 30. The n squared and the n to the 4th have exponents, so they get added and we get n to the 6th. 4, we just have the same base again, our x's, so we add the exponents, x to the 7. Number 5, that last x needs a 1. 6 plus 2 is 8, plus 1 gives me x to the 9th power. So you'll see that a variable base does not change how the property works in regard. So now we're looking at the second property. The second property is known as the power of a power property. So to find a power of a power, we're going to multiply exponents. What I want you to remember is basically we're just going to distribute. We're going to take the exponent outside the parenthesis and we're going to multiply it to the exponent on the inside. Take the exponent outside the parenthesis and multiply it to the exponent inside. So this first problem is going to become 2 to the 15th. 3 times 5 is 2 to the 15th. Number 2, the 4 outside gets multiplied to the exponent of 2 inside, giving me x to the 8th. Now number 3, I wanted you to see that this works the same whether I use brackets or parentheses. The 5 that is outside is going to multiply times the 2 that is inside, and I get negative 6 to the 10th power. Typically, if I'm working with a negative base, I like to write that negative in parentheses. You don't have to, it's just something that I like to do. So, here's 5 example problems. I'd like you to try them, see what you can come up with. Pause the video, and then when you're ready, turn it back on. So for the first one, take the exponent outside and multiply it to the exponent inside. Don't even worry about what your base is. That y plus 2 is your base. It's not going to change. It's going to stay y plus 2. So I get y plus 2 to the 12th power. 7 times 2 gives me 4 to the 14th. 5 times 4 gives me negative 2 to the 20th. 6 times 3 gives me n to the 18th, and 5 was just like the first one. I'm going to get m plus 1 to the 20th, 4 times the 5. So, power of a product. Basically, we're just going to expand the distributive property now. Now what happens if I have more things with exponents in the parentheses than just one base? And basically what it is we're just going to distribute the number outside the parenthesis to each piece inside that has an exponent. So the exponent outside the parenthesis is going to get multiplied to each exponent inside the parenthesis. So looking at the first one, even though they're not written, the 24 and the 13 have an exponent of 1. So 8 times 1 gives us 24 to the 8th power, times 8 times 1 gives us 13 to the 8th power. And that's your final answer. We don't want to know what 24 to the 8th is. We don't want to know what 13 to the 8th is. And 24 and 13 are different base values, so we cannot combine them together. Now in problem 2, I actually have 3 separate pieces. I have the 9 with an exponent of 1, an x with an exponent of 1, and a y with an exponent of 1. So the 2 that is outside has to multiply to each of those 3 pieces, giving me 9 squared, x squared, and y squared. Each piece had to be multiplied by the 2 outside. 2 more real quick. In problem 3, I have 2 pieces again. I have the negative 4 with an exponent of 1, and I have the z with the exponent of 1. And the 2 has to multiply to each of those exponents, giving me negative 4 squared and z squared. Problem 4 works the same way, but now that negative is outside the parentheses. The 4 has an exponent of 1 still, and the z has an exponent of 1 still. What's different is how you write your final answer. This time you have to include the parentheses because of that negative out in front. So 2 times 1 gives me 4 squared. 2 times 1 gives me z squared. In the first problem, only the 4 was negative. In this second problem, we're saying whatever 4 squared times z is, whatever that answer is going to end up being negative. So it's slightly different in the way the problem is written. So now we're going to take all the properties we learned today and we're going to put them all together. Always start with parentheses. So in the first problem, we have a 1 there with the 2. So the 2 outside the parentheses distributes to each piece inside, giving me 2 squared x to the 6th times x to the 4th. look for like terms or matching bases, and we're going to add their exponents together. So 2 squared x to the 10th is my final answer. In number 2, I have 3 pieces. I have a 9 with an exponent of 1, an m with an exponent of 3, and an n with an exponent of 1. I'm going to multiply the 4 that is outside to each piece inside, giving me 9 to the 4th, m to the 12th, and n to the 4th. Last one, both 5's end up with an exponent of 1, and inside the parentheses I have 2 pieces. So the 5 to the 1st I'm just going to rewrite, times 4 times 1 is 5 to the 4th. 4 times 2 is x to the 8th. Like terms get added, so 5 to the 5th, x to the 8th. And that's the end of the first part of this lesson. You should have a worksheet to try for homework. If we've already done this in class and you're just using it to review, I would pull out the worksheet, look back over it, or maybe try to find some practice problems in your book as well. Alright, so now we're back for day 2. So we have our warm-up again. Go ahead, try the warm-up when you think you have it ready. Unpause the video, and I'll go over the answers with you. So for the first one, you have 0.25 to the 3rd power, and when you evaluate that in your calculator, you get 0.015625, and you would just leave that as a decimal. For the second problem, you have 3/5 squared. That ends up being 9 over 25 because I squared the 3 and I squared the 5. Or if you happen to have it as a decimal, which is fine, it's 0.36 as a decimal. Today we're going to be looking at what happens when we divide with exponents, and we have 2 properties to look at. If we're dividing powers with the same base, instead of adding them now, because when we multiplied we added, so now when we divide we're going to subtract. Multiply, add, divide, subtract. So looking here at the first one, we have 7 to the 6th over 7 squared. Our bases have to be the same. And you always do the numerator minus the denominator. 6 minus 2 is 7 to the 4th power as our final answer. Again, if you can do the subtraction in your head, you don't necessarily need to write this second step. So in number 2, my base is going to be 5. And then 8 minus 3 is 5. 5 to the 5th. In problem 3, we're going to split it up a little bit. I'm going to keep the x's on one side of the fraction. I'm going to keep the 4 and the 10 that don't have any exponents with them over on the left-hand side. The 4 over 10 we're going to reduce like normal. Divide top and bottom by 2. And that's going to give me the fraction 2/5. Now I'm going to look at the exponents, the x to the 8th and the x squared, and I'm going to subtract them. 8 minus 2 gives me x to the 6th. In problem number 4, I want you to notice that we really have 3 different groups that we're going to be working with. We have the 2's, we have the 3's, and we have the 5's. And each one gets subtracted on its own. So 2 to the 5 minus 2 power is 2 to the 3rd times 3 to the 5th, 3 to the 4th, 3 to the 1st. And the last one, remember that the 5 in the denominator has an exponent of 1 with it. 2 minus 1 gives me 5 to the 1st. So go ahead, I'd like you to try these 2 on your own, see what you can come up with. Pause the video, try it, and then when you're ready, unpause, and I will go over the answers. Alright, in number 4, this was just like problem 3 we just went over. You're going to split it up so you have the numbers on one side and your variables with the exponents on the other. The 7 over 21 reduces down to 1/3, and 9 minus 3 gives me 6. My brain was thinking too far ahead. 5 is where we're going to put what we did yesterday with what we're doing today. Start in the numerator and add your exponents, giving me 5 to the 12th over 5 to the 7th. Now we're going to subtract and get 5 to the 5th as our final answer. The second property for division is the quotient, the power of a quotient property. And basically all it's talking about again is the distributive property. We need to make sure we distribute the exponent outside the parenthesis to every exponent inside, whether it's in the numerator or the denominator. So in problem 1, I have 4 separate pieces. I have the 4, the x squared, the 5, and the y. The 4, the 5, and the y all have exponents of 1. The 3 that is outside the parenthesis has to multiply to each exponent inside, giving me a final answer of 4 to the 3rd, x to the 6th, over 5 to the 3rd, y to the 3rd. Let's see. And then looking at problem 2, we have the 5 outside, the 5 goes to the a, and the 5 comes down here to the b with the exponent of 1. Giving me 8 to the 10th over b to the 5th. And that's a 10, not a b. Maybe I can make that look a little nicer. Let's see. Yeah, it's a little nicer. 8 to the 10th. Over on number 3. They're not any harder, they're just written a little differently. I'm actually going to make the second exponent into a fraction. To multiply fractions, we multiply straight across the top, giving me 3 to the 5th, and straight across the bottom, giving me 3 to the 3rd. I subtract my exponents, and that gives me 3 squared as my final answer. 4, we have to do a little bit of distributing first. So 1 to the 3rd over 4 to the 3rd. Well, 1 to the 3rd is really just 1. So I have 4 to the 3rd times 4 to the 9th over 1. Again, I'm making the 4 to the 9th over 1 into a fraction. So 4 to the 9th over 4 to the 3rd, when I multiply straight across the top, straight across the bottom, that's going to give me 4 to the 6th as my final answer. In class, we did a little bit of work where we looked at some fractals and fractal trees and those sort of things. You can certainly browse these two websites if you would like to see what fractals are about. It's a nice extension of working with exponents. It's nothing that's actually going to be on a quiz or a test. Homework, worksheet. If you have the worksheet in front of you, make sure you go over it. You can go back, look at some of these example problems, see how they were set up, pause the video where you need to. If you've already done the homework, I would suggest getting it out and reviewing with it. All right, last lesson on exponents. Today we're going to be focusing on negative and 0 exponents. But first, let's start with the warm-up. Try these 4 problems on your own, and then once you have them solved, unpause the video and I'll go over the answers with you. So for the first one, we're going to add the exponents, giving me b to the 16th. In the second problem, we're going to multiply the coefficients, or multiply the whole numbers, giving me 3 and 2, which is 6. And we're going to add the 4 and the 2, which gives me g to the 6th. In number 3, we're going to subtract our exponents because it's division, giving me z to the 6th. Now, problem number 4, that's where it throws all of it together. Start in the numerator. Multiply your numbers, add together your exponents. So I get 48 z to the 11th over 27 z squared. Split this into 2 problems, the numbers and the variables with the exponents. 48 over 27 will actually reduce, divide top and bottom both by 3. That's going to give me 16 over 9. Subtract my exponents. 11 minus 2 is z to the 9th. So the final answer is 16 over 9, z to the 9th. So today we're looking at negative and zero exponents. On their own, negative and zero exponents aren't real difficult, but it's when we pull it all together and try to throw it in with the product properties and the quotient properties that we really have to keep everything straight. But for right now, let's just look at them separately. Zero property is one of my favorites. Anything to the power of 0 is 1, regardless of what it is. So 5 to the 0 power is 1. X to the 0 power is 1. 126 to the 0 power is 1. Anything at all to the 0 power just turns into a 1. Not an exponent of 1, not a fraction of 1, just the whole number 1, and always positive. Negative exponents, on the other hand, really not any more challenging. We just have to kind of wrap our head around it a little bit more. What it's saying is a to the negative n power is 1 over a to the nth power. So a to the negative nth power is 1 over a to the nth power. Basically, what negative exponents are looking at is the fact that they're in a fraction. Okay, we're always going to look at these as though they're in a fraction. The negative means the piece is not happy on whatever side of the fraction it's on. So if you have a negative exponent in your numerator of the fraction, you're going to move it to the bottom and make it positive in the denominator. If you have a negative exponent in the denominator of your fraction, you're going to move it to the numerator and make it positive. That's all the negative exponent is telling us. It's telling us to move the pieces either from the numerator to the denominator or vice versa. So let's look at this first one here. We have 3 to the negative 5th, and I'm going to make it a fraction. I'm going to make everything a fraction today. So I have 3 to the negative 5th over 1. The 3 to the negative 5th is not happy where it is. It wants to come to the bottom of the fraction, becoming 3 to the 5th. Well, that's nice, but if I have something in the denominator of a fraction, I always have to have something on the top. So in this case, it's going to be a 1 on the top. Second problem, I have two pieces. I have an m to the 0 power and I have an n to the negative 4th. Always start with anything with a 0 exponent first. M to the 0 power is 1 times n to the negative 4th. Again, I'm going to make it a fraction. The n to the negative 4th tells me that it wants to go down into the denominator, becoming positive. And I put a 1 in my numerator. So my answer becomes 1 over n to the 4th. In problem 3, hopefully you see that there are 3 pieces, a 16, an x to the negative 6th, and a y. Only the piece with the negative is going to move. So on the top of the fraction, the 16 and the y are going to stay, and only the x to the 6th moves to the bottom and becomes positive. In number 4, it also works if you have a negative in your denominator. This is going to become 2 to the 3rd over 1. It comes back up to the top. So in this example, this is where we're going to look at everything from the past 3 days, and we're going to put it all into a variety of different problems. So we're going to see product properties, quotient properties, and negative and 0 exponents. I'm going to write up here, there's 5 steps that we're going to follow. I'm going to have to write them up here and then erase them, but at least you'll be able to see them. You always want to start with parentheses. Parentheses. So anytime you see parentheses in a problem, start there. The second step that you always want to work with next is you want to work with your negative and 0 exponents. 3, anything with multiplying exponents. But remember, multiplication, we're really going to be adding if we're working with exponents. 4 is our division, which will be subtraction if we're working with exponents. And the 5th and final step, always double check. We never want to have negative exponents in our final answer, so always look over the problem at the end and make sure that you don't have any of the negative exponents. Now, unfortunately, in order to be able to solve these problems, I need to use my eraser. Hopefully. Maybe not. Yeah, there it goes. To give myself a little bit of white space. But as we're going over these, I will be going down through the 4 steps. And you can always kind of reverse back in the problem if you need to. And for some reason, it's not going to let me erase my parentheses. Let's try. No. All right. Well, for some reason, it's not letting me erase those words, but we're going to kind of forget about them. All right. So, starting with number 1. 5 to the 10th times 5 to the negative 6. No parentheses, but I do have negative exponents. So this is going to become 5 to the 10th over 5 to the 6th. The negative exponent goes down into the denominator. This is now division, so I'm going to subtract and get 5 to the 4th power as my final answer. Problem 2. I have 3 pieces. I have an 8, I have an n to the negative 3rd, and I have an n squared. No parentheses, so I'm going to start with my negative exponents. The 8 does not have a negative exponent, so the 8 stays on the top of the fraction. The n squared stays where it is, and the n to the 3rd drops down to join it, and it becomes positive. On the bottom now, I have my multiplication, so I'm going to add the exponents. The 8 stays where it is, and 2 plus 3 gives me n to the 5th. So 8 over n to the 5th. 3 is where we bring the parentheses into the problem. Remember that the number outside gets multiplied to each exponent inside the problem. So this becomes 4 to the negative 4th. Negative means you need to bump it to the other portion of the fraction. So this will become 1 over 4 to the 4th. In 4, we have 3 pieces. 2 to the 1st, x to the 1st, y to the negative 5th. Each one of those 3 pieces has to get the negative exponent. Has to get the 3 that is outside. So that's 2 to the 3rd, x to the 3rd, y to the negative 15th. The 2 to the 3rd and the x to the 3rd are going to stay where they are, and the y to the 15th is going to bump down into the bottom of the fraction. So now problem number 5. Problem number 5 is where I've taken everything from the last 3 days and I've thrown it all into one problem. As long as you follow the 5 steps, parentheses, negative and 0 exponents, multiply, divide, double check, and you just take your time and write everything out, you'll be okay. We're going to start with the parentheses, so 2 to the 1st and x to the 1st. The 2 that is outside multiplies to each piece inside. That gives me 2 to the negative 2nd, x to the negative 2nd, y to the 5th, over negative 4x squared, y squared. I'm going to jump down here because I have a little more room. Next, I'm going to do my negative exponents. The negative exponents are going to bump into the denominator. So the only thing left in my numerator right now is y to the 5th. In the denominator, I have negative 4 times the negative 2 squared that was up in, it shouldn't be negative, the positive 2 squared that was up in the numerator. I have the x squared that was in the denominator. I have the x squared that was in the numerator that got bumped to the denominator. And I have the y squared from the denominator. I now have like terms on the bottom, so I can add those exponents together. So y to the 5th over negative 4 times 2 squared times x to the 4th times y squared. And I know I'm cramming it in there over on the side, but I want to make sure I have enough room. Last step, we have the y's. The y's are like terms, but they're being separated right now by division. So instead of dividing exponents, we're going to subtract. 5 minus 2 gives me y to the 3rd in the numerator. The negative 4 is still in the denominator. 2 squared is still in the denominator, and the x to the 4th is still in the denominator. And this becomes your final answer. This negative 4, talking about it briefly, this is not a negative exponent, it's a number. Only negative exponents move between the numerator and the denominator of a fraction. Negative numbers just stay where they are unless they have an exponent associated with them. In this case, it did not, so the negative 4 just stays as a negative 4. So we finally made it to the end of the exponents. You should have a worksheet tonight for homework that would review just the 0 and the negative exponents. If you've already done that worksheet, go ahead, look over it, review it, see how it's going. And if you haven't done the worksheet, I would certainly go ahead and complete that.